Hello, welcome to a presentation here from the Forage Systems Research Center. I'm here with Shannon, ag engineer, and I'm an agronomist with MU Extension, and we're talking about an exciting project we have related to being able to do strip trials on forage systems. This is an area where University of Missouri is really taking a leadership role, and some of this groundbreaking research has been taking place at the Forage Systems Research Center. What this is about is we're trying to take the technology around strip trials, which is something that's been done by row crop farmers for a couple decades now, and we're bringing new technology so that we can do that same process in forage systems. So we're bringing the concept of on-farm strip trials onto farmers' fields using a new technology. Now, this technology is technology we've been using extensively at Forage Systems Research Center, also down at the Southwest Center, and also on some farms across Missouri, where we take a sonic reader system, put it on the front end of an ATV, it bounces sonic signals down to the grass and back up to the sensor, and then on the right-hand side here, you can see a graph of how we can map the height of the forage as we drive across the field. Now, this is, like I said, we've been doing this on the research centers now here for probably about 5 or 6 years. We're now working to convert this to a system that's available to farmers where we have an app to collect the data from the sensor. And I'm going to give a little example of that here, something that was put together by Ryan Locke to show you how this system works using the app. So a farmer would have the app on their phone and they'd have the sensor on their bike, and we'd go across the field. And here you can see the bike reader on the left and the app on the right collecting the data. And the app is recording the inches of growth here and also giving a visual about how much grass is there. And this application was put together to funnel information into the MU grazing wedge. And that was the original intent of this technology. And it's something that obviously, if you're interested in that from a grazing wedge perspective, it's a great tool. Today, really my goal and Ken's goal is to talk about how we're transitioning this technology, not just to look at the grazing wedge, but also to allow us to be able to use that app to collect data to do strip trials on farmer fields. So on the left here, I'm just showing how we collect data using the research data. And on the right, this is the same trial being collected by the application. So now what we're going to do is I'm going to switch over and have Kent talk about how we implemented a phosphorus strip trial on the Forage Systems Research Center, and as a model of how we're hoping farmers will be able to adopt this technology on their farm.
So what we did to initialize the strip trial at the Forage Systems Research Center, this specific trial, was we along with Dave Davis, superintendent at FSRC, we chose a field that was made up of some paddocks. We initialized some soil sampling on a grid, and this is showing the analysis of phosphorus and potassium on this field. We specifically want to look at phosphorus, and the reason potassium is there, we wanted to correct potassium from a variable rate technology standpoint that was independent from our phosphorus trial. Next. So what we did was we laid out some strips. These strips were 80 foot wide. Why 80 foot wide? That was the commercial applicator width that we could get. So also we're showing that any farmer could do this on their own farm with commercial equipment. So the P side of the trial was just in 80 foot wide strips, either 0 pounds of phosphorus or 50 pounds of phosphorus. And then underlying that was the correction of potassium and that would be the variable rate potash map for the area of interest. So we worked with a local MFA dealership out of Brookfield, and they used a spreader similar to this, an R4038 dry spinner spreader. That spreader happened to have 2 bins in it. So part of the project, we could actually apply the phosphorus side and the potassium side simultaneously at the same time. So bin 1 would have been phosphorus and bin 2 would have been the potassium, and they could be applied at the same time, and the strips could be applied. So one of the important things in a strip trial is to get as applied data. So this actually shows as applied data. The right-hand side is the potash map. Now, another input into this was adjusting. We applied the phosphorus in the form of DAP, which has a small amount of 18% nitrogen in it. So we adjusted a nitrogen rate accordingly, and that's why we see a lower rate in the phosphorus strips and a higher rate in the strips that did not have any phosphorus, just to even out the nitrogen application, eliminating another variable to see any response from phosphorus. So after the application was made, then we set up how we would collect the growth data or yield data, if you will, and run the Paddock Track and the ultrasonic sensor perpendicular to the strips, where we could then evaluate if there was any response to the phosphorus fertilization in the strips that received that. And this shows what we've seen so far over the growing season this year, that if you look, the dots that have a 0 in the graph, sort of an open circle, were no P, and the dots with the closed circle, the darker dots, you can see that we really didn't see any response at all on either of the sides of the trial this growing season. So we're not currently seeing any response to P, though we're also, another part of it is we're showing that the technology that we're evaluating seems to be working very well in how we can collect the data and evaluate growth in a fertilization trial such as the P trial. And then to further evaluate, looking on into the future, a couple of things we've done here just recently. We've applied a little bit extra nitrogen to see if we get a little bit extra response. So this is the same field. We applied 4 strips of 50 pounds of nitrogen going again perpendicular along with our bike reader to see if we can see any response later on into the fall here of nitrogen in that trial as related to the P response. And then another trial that we initiated because seems we're having some success is this basically a nitrogen response trial to get a better understanding as we travel a perpendicular across these strips. Do we see a bump in our readings from the Paddock Track or the ultrasonic sensor? So here we've got strips of 150 pounds of N that we actually collected. We're using some other technology that's a cloud-based technology that allows the farm to collect as applied information on the farm of, in this case, the yellow strips are where the tractor and fertilizer cart drove to apply some 150 pound N strips. In between, there's 0 N that has been applied, and then a small shorter strip clear to your right. I believe we applied 225 pounds of N just as a sort of a reference strip, if you will, to look at nitrogen response.
So that's a window into a new project we have up at the Forage Systems Research Center. We're trying to transition an exciting technology that is the Paddock Track System, where farmers can measure the amount of grass on their farm and use it for doing grazing wedge. And we're trying to leverage that technology so that we can do strip trials on farmer fields. And we look forward to keeping up with you as we move through the winter into spring and document whether we see responses to that nitrogen across the field there at the one field, and then also look at that nitrogen by phosphorus interaction in the first trial. So thanks for the opportunity to meet today. And on behalf of Ken, Ryan Locke, Dave Davis, and Nick Matheny over at the Forage Systems Research Center, thank you for joining us today.